All right, so today we have 3 learning goals. Create an absolute value equation or inequality to model a contextual situation. So that would be in the context of the real world. Verify the solutions of inequalities and interpret the reasonableness of the results. And explain the solution and interpret solutions using the context of the problem. So today we are going to use absolute value in the real world. The average number of seeds in a package of cucumber seeds, why does it say that twice? Let's say in a package of cucumber seeds is 25. The number of seeds in the package can vary by 3. What are the maximum and minimum number of seeds that can be in a package? Now, that question could be...
Is that a highlight or...
No, that's a cross out. Somebody just typed it twice. That question could be like a second grade question, right? What's the maximum and minimum number? But if you turn it into an absolute value problem, now it is a high school problem. So instead of just answering the question, we're going to start by writing this as an absolute value equation. Let's think about what this would look like on the number line. So here's my number line, right? 0 is like all the way over here, and 25 might be like right here. It can vary by as much as 3. So it can vary 3 below, and it can vary 3 above. So we do know that if this were a second grade problem, our answers would be between 22 and 28, right? Be between 22 and 28 seeds. Well, that would be if it was an inequality. It actually just asks the maximum and the minimum, so I'm just going to keep the points. I'm not going to connect them. Okay? So the maximum and the minimum would be 28 and 22. But we need to express this as an absolute value inequality. So remember that we talked about absolute value last class as the distance from 0. So we said absolute value of 5 is 5 because it's 5 away from 0. But then absolute value of negative 5 is what? 5, because it's also 5 away from 0. We've moved our center point from 0 to what's our center point now? 25 is our center point. So we moved our center point 25 to the right. Do you guys remember when we move things left and right with transformations that it wasn't x plus 25, it was what? It was x minus 25. So our absolute value center, because our center moved from 0 right 25, it's going to be x minus 25. And how much is that distance from 25? How far are we from 25? We're 3, right. Because we're either 3 below or 3 above. This is the absolute value equation that would get you the maximum or the minimum. And we can check that by solving it. So if I solve it, I have x minus 25 equals 3. And x minus 25 equals negative 3. And I can add 25. Okay, so I'm going to pause for about 30 seconds for processing, and then we're going to put a little formula on this. All right, so our formula is going to have that absolute value, and because it was that shift right that made it x minus 25, the shift might be right or it might be left, but it's always going to be x minus whatever is that center. All right, so the center was 25 because that's how many cucumber seeds were supposed to be in there. So x minus the center and what that's going to equal is the distance from the center. Now, you could just write distance, but that you might be thinking to yourself after reading your notes, like, what does that mean, distance from what? So it might be better to just write distance from center.
I have a question.
Mm-hmm.
You said that it's minus whether it's on like the negative side or the positive side, because if it's on the negative, then you switch to positive.
So the minus is part of the equation, but if the center were a negative number, like say -5, right? Then it would be x minus -5, which becomes x plus 5, right? And so that's going to work out exactly the same as our transformations. If we shift to the left, it will end up being a plus. Okay, other questions on that one? All right, I'm going to have you guys try this one. I am going to read it through with you and see if we can make some sense of it before you get started. Oh, actually, we didn't write our sentence. We need to write a sentence to interpret our answer. And so it's really just answering the question. What are the maximum and minimum number of seeds that can come in the package? So the minimum number of seeds is 22, and the maximum is 28. All right, and that is an important part of the answer, being able to write that in a sentence. So if you just have 22 and 28 on your paper, if that were a quiz, you would lose that point for interpreting your answer.
Miss Burrell,
Yes.
for questions like that, like, this is something you can figure out without doing the math.
So this answer is without the math, right? But if this were a quiz question, you would probably have about 4 points on it. One would be for setting up the absolute value. One would be for solving the absolute value.
Yeah.
One would be, well, that would be for that. And then one would be for your sentence, right? So the question is asking how many would come in the package. Sure. Like, yeah, you could do that from second grade math. But setting it up as an absolute value is what's making it an algebra problem. I hear you, but I'm telling you that this is what we're learning right now is about absolute value.
Okay.
All right, let's read the next one. The average January temperature in a northern Canadian city is 1 degree Fahrenheit. The actual January temperature for that city may be 5 degrees warmer or cooler. What are the maximum and minimum temperatures for this city? Now remember, I don't want just those numbers. I want the steps. I need you to write an absolute value equation. I want you to solve it. And then I want you to write a sentence of interpretation. All right, guys, let's see how you did. So if we use the formula, oops, you're frozen. If we use the formula, x minus center equals the distance from the center, then we'll start with absolute value x minus, what's the center? Anybody else get 1 for the center? Good, okay. So that's what we expect the temperature to be. So that's our center. Good morning. And then that's going to equal the distance from the center. And how far can we go from the center? 5, good. So that's going to be a 5. And then we're going to solve that. Okay, and then remember to get your 2 solutions. Okay, and if you have already written a sentence of interpretation, raise your hand so I can see who's gotten that far. All right, I would say about 2/3 of you. Very good. Does anybody want to read their sentence? Go ahead, Hannah.
The minimum temperature is -4 and the max is 6.
Nice. Thank you. The minimum temperature is -4. I'm going to put degrees Fahrenheit, and the maximum is 6 degrees Fahrenheit. None of my pens are nice today. Problems. Try this one. Okay, so make sure you're caught up and then look ahead to the next page. I believe on the next page we're going to do some inequalities. Yep, we've got some inequalities coming up. They're not much harder though.
Less than looks like.
That's how I remember it.
That's the only way.
Elephants can raise and lower their body temperature in response to extreme environmental conditions. Veterinarians say that an elephant's body temperature shouldn't vary by more than 2 degrees from the norm. All right, so this is the normal elephant body temperature, and it shouldn't vary by more than 2 degrees. So that means that it's going to vary by 2 degrees or less. Let's see what that might look like. Now again, when you solve these, it's not necessary to make a number line, but it does help me understand what I'm looking at. So here's my middle, 96.6 degrees. And if I go 2 more than that, it would be 98.6. And then 2 less would be 94.6. And this time I am connecting the points because I'm talking about an interval. I'm not just talking about the maximum and the minimum. So if they just ask you the maximum and the minimum value, you're just looking for numbers, so that's the equation. But if they ask you for this interval, then you're going to do an inequality. And these are all the numbers that are less than or equal to 2 away. So we're going to start with the same formula, x minus the center and the distance. All right, and you have to think about if it's going to be a less than or if it's going to be a greater than. So these are the distances. Are these the distances that are less than or equal to 2 or greater than or equal to 2? Can the elephant's body temperature be, yes, it's less than, because it can't be more than. If it was more than 2, they're saying that's not possible, okay? So this is less than or equal to 2. Okay, so then when I'm writing the one that is specific, and actually I'm not answering the question that they asked, I'm answering this question here. I'm actually not going to do A. Sorry about that. I'm just going to do it this way. So x minus the center. Yeah, you can write under B, or you can just do an arrow like I did. X minus the center is less than or equal to the distance. And then I'm going to do x minus, what number's in the center? Yep, 96.6. 96.6 is less than or equal to, and how far can you be? 2, yeah. And why did I put a line there? I don't know. There's the line, 2. Sorry, a lot of typos today. Absolute value, x minus 96.6, less than or equal to 2. And that was actually the answer for B. We didn't do A, because I didn't feel like it was a necessary step. And then for C, it says to solve the inequality. So we're going to solve this. And I have x minus 96.6 less than or equal to 2. X minus 96.6. Instead of less than this time, I have to put what? Good. Greater than or equal to what number? Negative 2. And we're going to solve these two. All right, so I want to remind you that when you have this inequality that is between two numbers, you can write this as a single inequality with the x in the middle. Take a moment and try to do that. That's going to be good practice for you. Try to write those two inequalities as one inequality with an x in the middle. Okay, so I told you the x goes in the middle. And then you guys remember that the smaller number will go on the left and the larger number on the right.
That's what you get generalized.
And then are your inequalities going to be less thans or greater thans there? They're both going to be less thans because 94.6 is less than or equal to x. That's smaller than x. And x is less than or equal to 98.6. X is smaller or equal to this number. This is how you say that x is between these two numbers.
You said it says that x is between the numbers?
Mm-hmm. Just like we showed on our number line right here.
Okay. Yeah.
All right, I want you to try the you try problem now. Okay, you are planning a car trip, but you don't know how long it will take. Your friend says it should take about 45 minutes, give or take 10 minutes depending on the traffic. So we decided we're going to just skip right to the absolute value inequality. We're going to use the format x minus the center. And if it was an equation, it would equal the distance. So I had a good question, like how do you know if this is going to be a less than or a greater than here? Okay, so if your friend said it will be more than 10 minutes away from 45 minutes, that would be a weird thing to say because he would be saying either it's going to be less than 35 minutes or it's going to be greater than 55 minutes. Like, why would it be that, right? Why would it not be something in the middle? But if he had said that, that's what it would mean. In this case, your friend is saying it's going to be within 10 minutes of 45, and so that means it's going to be less than or equal to 10 minutes away, okay? Less than or equal to 10 minutes from the 45. For the word problems, they will mostly be that. I did at one point, like one problem that you're going to get at some point in the next few days has a greater than just because I wanted to make it a greater than so you would see one, but these word problems are mostly going to be less than or equal to. So then here I'm going to actually write it for this situation. X minus, what's my center number? 45, good. Is less than or equal to, how far can we be from 45 minutes? 10 minutes. We can be up to 10 minutes away from that. Okay, so then we're going to solve that. Less than or equal to 10. Greater than or equal to negative 10. And then solve it by adding 45. So x is less than or equal to 55. X is greater than or equal to 35. So we are going to put this into one statement, and we're going to write words, both.
Can you do a number line for it?
Sure. Yeah, the number lines can be helpful in just interpreting what you're looking at. So we know 45's in the middle. And you can make 10 little lines if you want, but I'm just going to tell you here's 35 and here's 55. And so our time range is going to be between 35 and 55 minutes. So x could be any number between 35 and 55. Okay, so you always just write it from the smallest to the largest. Smallest is 35, the largest is 55, and x could be any number in between. All right, so x is bigger than the 35. 35 is less than the x. X is less than the 55, or 55 is more than the x. They both point the same way. I see a lot of people, they get confused just about how to write that one statement. I see them like both pointing out or both pointing in because they think they have to be different. Because of the placement of the x, that's how they end up being different, but they always both point to the left when you're writing them together like this.
Will they always point the same direction?
If you're putting them together. Now remember, if we have a problem like last class, remember last class we had problems where it was greater than or equal to? Then you couldn't put them together in one statement. All right, so we had some problems last class where you couldn't put them together in one statement. That happens when your arrows both go out.
Oh, is that just...
And that's when you just write the two separate statements with or in between. All right, so let's write the words. Your trip could be between 35 and 55 minutes. Probably just depending on traffic.